So far, so good. Clippy can help. Clippy pops up and is like, I can see you're trying to do your nails fabulously. Let me help you with that. Yeah. The network crashing kind of discombobulated me a little bit. A network crash. I have like this fiber internet modem thing, and decided it was just gonna like restart randomly. Not even like 30 seconds after I clicked the start stream button. I was like, why am I dropping frames? Oh, because nothing's working. So I waited for it to do its thing, and then it came back, and then it gave me time to eat my food. And now we are maybe good, kind of, sort of, probably. Maybe kind of, sort of, probably. I'll drink myself some water or something. Maybe actually start applications up that I need. Just things that we do at the beginning of streams. That's all. Anyways, hello and welcome to Sergeant Pepper and the Nympheus and the keyrim of the underscores. I'll say I didn't sleep very well today, but like I feel pretty decent in spite of that. Automate the process of opening all the apps, putting the windows in their place, starting the sessions. If you have a lot of things to open, that's actually kind of, sort of helpful. My Windows computer actually has like a startup script of sorts that I wrote that's supposed to launch a bunch of applications every time it starts up. It doesn't work very well. It does kind of get most of the basics, but like, it really needs some more features. And then the one thing that I sort of have to manually restart every stream is like the 3D, the 3D model, just rendered through like VC Face. VC Face is such a jank piece of software. Like, what the hell? And it's not even doing the tracking part. It's just doing the rendering part. But if I leave it running too long, the frame rate goes down the tubes. It drifts out of alignment randomly. Maybe one of these days I'll actually, maybe, probably get around to like that rendering thing that I was so very much trying to attempt. It's been kind of iffy. It's been so very iffy. I guess in some way, I do have little scripts for various things. Like, I have a helper script that launches like the tracking program. I have like a helper script that runs something else. I don't remember. Definitely lack for automation. Hello again. To the Moalon. Moalon? What if you want to mow a lawn? Brr. Let's chop that grass. Be like, E. I don't know if that's actually the way to go or not. Very E. I kind of want this view, I guess. Whilst I try to, I don't know, breathe? Breathing might be nice. get my throat clear enough to actually talk. That'd be great. That would be excellent. Maybe we could try that. Maybe we can't. I don't know. Got that ferret walk. We got that ferret walk. Very important. Yeah, I'm at maybe a little bit slightly worn out. And it's not even that far into the stream yet. Oh yeah, yeah. Yeah, I'm awake, really. Really, really. I think. What do we have here? We have a raid from... How do you pronounce this? Exilium AI? Hello, hello. Welcome, welcome. Don't be fooled, this is the beginning of the stream. I'm a little bit tired, because it's early. In my day, at least. And then waking up is not very... It's not very expeditious. Takes me a little while. What was the Exilium AI up to? How was the stream? Welcome, welcome. Where's that thing at? What do we do in here? I don't even know. I don't even know. I have no idea what's going on with my, like... What's it called? What's it called? We need to, maybe we shout out the Exilium AI. Pretty fearsome. Very. Yeah. The spreadsheet says nya. So welcome to spreadsheet says nya. Exilium AI. Navi is lazy. Crazy Games 10. And Azrael IO. Colonoscopy. Gotta find all the people. Say hello to them. Greet them all. Hello and welcome to the F Mega. F Mega. Are we just gifting subs everywhere now? Wait, are we maximum re? Oh my god. Oh my god, it's too early for this. It is too early for this. I need to drink more water sometimes. Yeah, great. Yeah, great. Yeah, right. So now what am I? What was I doing? That's the real question here is what the hell was I doing? I think I was planning things? No, I was setting things up, and then I finished setting things up, and then I got derailed slightly, and oh, what was I doing before that? I was trying to figure out what to do exactly, as opposed to what to do vaguely. No, what was I doing? I was setting up the playlist. I think. It's gonna tweak that. Tweak that, and then I didn't. Let's see. Let's grab stuff out of there then. Move some of that. Maybe like right above there. Just rearrange this. Rearrange some of that. Yeah. Yeah. One of those up there. Yeah. Put that over there. This over here. And then we'll put this one over there. Now I can go over there. Hello and welcome to the Lotus. Kuxiang. That 3 a.m. schedule? Maybe? Maybe not? I'm not that crazy, am I? Am I? I don't know. I don't think I wake up that early. Or do I? Yet. Don't put that evil on me. Don't put that evil on me. Make me wake up late. You can put that evil on me, though. Yeah, clearly. A minute of ads. Why are we doing a minute of ads? Why would you do this? Why would you do this? Why would you do this? Ay, ay, ay. Ay, ay, ay. Ay, 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 ay. Do I have anything else that I need to set up? That's something else. Would you put that evil on me, Ricky Bobby? Oh no. Oh no. Right, oh no. Let's see. Let's go back to this view. Because if there's one thing I know for certain, it's that we're gonna do some more key engine. We're probably gonna do some more input stuff. Get that flavorful input engine to work, kind of. Maybe. Hopefully. An attempt will be made. Some of that bad apple may suck. Some of that delicious bad apple suck. What if there's caramel bad apple suck? What if we need this? Yeah. Yeah. So last time I was working on this very sort of infamous input system. Where the hell did I go? And if we run this, it displays like all the things. Hello and welcome to the Code Nightly. Displays all the things. The thing that I built last time was like these categories that the particular input device fits into if it's a keyboard. So like if something is actually a keyboard, it will probably support keyboard, function key, maybe some of these other ones. Keyboards are pretty broad spectra. If you have a game controller, those usually fall under the gamepad category. Cameras apparently have the camera key. So I put that in its own category. A MIDI controller. I don't know if a MIDI controller would show up as an EV device. Kinda doubt it though. You suck a bad apple. When may suck a good apple? I don't know. This is a good question. It's a very good question. Also, welcome and hello to the I Love My Lazy Monkey. As far as I know, MIDI devices, those have their own device node in the device tree as opposed to an input device. And you might kappa, but like this is actually a thing that I was considering adding to like the Windows version of the engine. It's not as outlandish as you might think. Get some DSP primitives. You can build the audio graphs. Like the super collider. But not as large. I regret to inform you that I don't know of any. A super mini collider. Super collider. There is some software called Super Collider. Very true, very true. Very hello, very hello. Hi, welcome, welcome to the Huta 2H. I see synth and Rust. I feel like that would make it go slower. Or not slower. I think that I don't think that would be. I don't think that would be more inefficient. Size-wise, like Rust is Rust code be kind of compiles to stuff that tends to be a bit larger than C or C++. For certain situations. There's a piece of software that I use called Sonic Pi. And it's basically just like a conglomeration of things. And one of the components is that it runs the Super Collider service to do all of its synth. Oddly enough, it's also got like a Ruby interpreter and like like an Erlang VM and like an Elixir compiler or something. Like, what kind of amalgamations of technologies did they put together to get this thing to work? I have no clue. And then Meisaka comes along and uses it for microphone amplification. Hello and welcome to Richard Skull. I use it for other things, of course. Like, every time I do...
The evil effects. You know the evil effects, right?
That's all Sonic Pi and Super Collider. I just have like a bunch of like little programs queued up, and I switch between them to turn the effects on and off. Something I was actually looking into but never actually finished was that I wanted to do OSC. I wanted to implement OSC in my Twitch service. So I could send OSC like packets to Sonic Pi to have it switch the different effects automatically. But of course, I never put together the appropriate interface for that. I need to get on that OSC thing. Cause I wanna like port over all my model tracking to something custom, which means feeding like the tracking data into something and then spitting out OSC. Because apparently VC Face and some of the other VTuber things use a special variant of OSC called VSC. There's just a bunch of special OSC messages for posing avatars based on like tracking data. Damn it, now you're giving me ideas. Now you're giving me alternate stream ideas. This is way more interesting than this. That sounds way more interesting than like what, trying to categorize input devices. Just gotta write that down. I probably do have it written down somewhere. Although probably not in the place that I think that I should write it down. I don't know. Do you have it? If anything, it would be in here. One moment. Yeah. Am I on the E? Oh, I didn't put that one. I'm gonna turn that one off. I'm gonna put that one. Yeah. Such distractions. Sometimes distractions happen. Then I lose my place. A little bit. Did you? OSC. I should write this down. Like, I talk about it occasionally. What was that other one? Custom VSC service. It's the wind-up boy. Hello, hello. Hello, 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 welcome, welcome. Yeah, I don't think we're doing the, I think we're keeping track of these inputs. Or evaluating the inputs. If we... If we have like libseat handling things, yeah, we need some of that maybe. I'm gonna say maybe. So, you know what else we don't have? We don't have a good way of detecting whether or not there are changes in the desktop. Like if we plug in an input device, it doesn't get detected at all. I think if we unplug an input device, that probably also wouldn't get detected. We like listen to that one again. I like that song. Alright, so what do? You open the device. And then, what do we got here? Dispatch. Not sure what dispatch does. Let's see, -1. Libseat might wait indefinitely for data to arrive. 0. No wait. Don't wait. It's the Navi who is lazy. Again? No? Should have been one. I hear one from one of the inputs. HDMI? I guess I don't hear one on default. I don't know why, but like one of the windows is supposed to do the playback. Well, this one's actually on the Windows side. Like I don't know why. You work? You're supposed to work. I guess I didn't activate the page. I guess I keep forgetting that I have to activate the page. No wonder that doesn't work sometimes. Yeah, I should just like have it route that to like the sound effects engine. And then it can just do the thing. I can take care of it for me instead of having to like make sure I have multiple possible instances of the the other thing, the dashboard or whatever. Let's see, how do you open device? Like so? You know, this could technically fail if the device doesn't exist. Right? I'd say like maybe. Maybe. Let's see, what do you do? You want to open this if you have this back end. Maybe like else? Try to open directly? Maybe? What was that other? I thought there was another thing you had to do with. I don't think we want to close the file descriptor. I think we want to leave the file descriptor open. Maybe? What do you do? Close the device. Pullable connection something or other. I guess that's sort of useful. You request that the seat switches the session to the specified session number. Open. Take control of the seat. What if I don't want to take control of the seat? Seat name. A seat name? Uh, uh. We can skip you. Let's see. So I don't want string. I want input prefix. Which is a dynamic variable containing the appropriate string. I'm gonna have that appropriate string, yeah? Yeah. So what do I want here? We want device scan data. I think we want device scan data. I need to clean this up a bit. We do continue. I think we can do continue. Maybe. Can we do hydrate? I think we can do hydrate. I think this is possible. Hmm. So I guess let's make a unique, and then there's that whatever it is, that device scan data. You can be device. Getting chibified. God, we got the way chibified. Oh no. Why do I have a random variable in here? E? We're getting hollow projectified. Hollow projectified? A 9 different prismatic fied? Yeah. Very yeah. Extra yeah. Peak avatar. Eee. Eee. I mean, you're not wrong. You're not wrong. If I didn't have enough things to make me look maximum jank, am I even foxing the right way? I don't know. Questionable. Very questionable. See, I think this has to go in the loop. Or at least, I think we'll put it in the loop. I think that makes some of the more sense, slightly. Almost slightly. And then, let's see, what else do we need? Oh, the prisms fell off. Yeah, that's not half bad. Not half bad of a look. I wonder which one that was. Probably like gamma something. Gamma beta stack? The very infamous gamma beta stack? No one ever does the gamma beta stack. Are we still like in bad apple mode? I don't even see it. Oh, there's a video. I was like, what is that? It's in video capture mode. That throws me off sometimes. because it supports not just bad Apple, but also like any videos that might be playing as part of the regular soundtrack playlist thing. Some of them are videos. Yeah. Uh-huh. Yep. Yep, 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 yep. Yep, 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 yep. I guess it's less noticeable because hollow projector. Yup, 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 yup. Yup, 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 yup. Yep, 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 nope, nope. Okay, why don't I put file descriptor thingy in here? Just try to try it. Try some of that. So I don't have to do that twice. What else do I need to do here? File descriptor that we get back. I wonder. I do very much wonder if this has anything. If this has anything. Really duplicate it. Maybe. And we duplicate it. Then what would happen if we were to close device? Yeah, we'll try close device. Just like read this or something. Where's my window at? This one. Close device. Get deferred to the back end. What are you? Stat device. Release device. This image. Typical May Saga. Stare at code, yawn repeatedly. Put everyone to sleep. Everyone was put everyone to sleep. Yes, this sounds like a great idea. Great idea. Absolutely, 100. Though I'll admit this is maybe not the most exciting part of the stream. What the hell am I doing here? We're duplicating file descriptors? Do I need to duplicate that? Can we just set? Delete you? And then I think there was like some array, some list. If it was not an array or it's a forward list. This is a forward list. Mm-mm. Mm-mm. It's a forward list of pointers. That's about as silly as it comes. What did you move you? Force you to move? We should change this to device scan data reference device. What do we got here? Device name? Can we give you string view? Yeah. Yeah. Full path. That is like input prefix. So we'll just copy that. And then it's always an and then kind of deal. Let's see, are there any more UVIO? See, we get from you. Version? Device ID? I think it would be device ID. to give it input ID. Want anything here or no? Right, yeah, we have to actually have to give the variable a name. Why am I so eek today? Why are we so eek today? Then we need the thing. Yeah, the thing. The thing. But not that thing. I'd be serious tired sometimes. We kind of went pretty intense. Kind of, sorta. It doesn't help that like I don't sleep a whole lot. Like I have the energy, and I don't have anything to do with it. It's quite peculiar that. Health 4. That's lovely. That's lovely. Lovely, I mean not. I'll even, I don't know, inval. Make this shorter. Maybe in a good way. I don't know if that's in a good way actually. Very We have excessively nested things. That's kind of fun. Let's see here. Oh, we got all these open functions. Sort of, maybe, probably. You know, scanning through all the devices is probably something that we need to do in a function. We can invoke this more than once. Like if things get deferred in some way, I'd be like, yeah, sure. We're gonna get rid of this. We're gonna get rid of literally all of that. It did not help. You, I think, you're supposed to be system path. Or whatever. tell which one is which, and then we want... I'm gonna grab pole. Pole is slightly better. Slightly. What are you? Timeout? Number of file descriptors. We have 1. Omega. It'll be one thing that means. Egoist just reappeared. Hello, hello. Welcome, welcome. Thank you, thank you. How good am I? We're doing pretty good. I didn't sleep good. Of course I didn't. It could have been anyone. But that would be very unlikely. It's sort of highly very unlikely. Let's see. Let's do the 2 milliseconds. Or was there some other version of poll? I could have swore there was like something else. Something else. Anonymous cheer. I don't know if they... I don't know if that's a thing so much. Struct poll FD. That's what you saying? Events? Poll in? Poll... error? Oh, there are 2 different kinds. Wait, there's so many different kinds. Poll hang up? This is ignored in the events member. Okay. Okay. Maybe. E-poll. Oh. I don't know. I don't know what to use. Does this system even have e-poll? I'm curious if like Linux has like completion ports or something. That'd be more interesting. Got interest list. Get the watch list. We're making the list. We're not checking it at all. We got system calls to create and manage an ePoll instance. Create. Turn a file descriptor. Interest in file descriptors is then registered via ePoll control. We got ePoll wait. This kind of does what I want. Is the ePoll file descriptor itself ePoll selectable? Yes. You cannot put an ePoll file descriptor into its own descriptor set. That's invalid. History. Linux 2.5. That's well supported, I'm sure. What are you, system? Get out of here with that. Let's get some of the good stuff. Maybe. Because I have to configure one of these. What do we got? ePoll create one. You and how are you different? ePoll 1 takes flags. And then there's what? Set close on exec. was that other one? Oh, IO control. What are you about? Poll budget. We're busy. And just a bunch of parameters. All the things you can find. What do you got? File descriptor, structure, max events, timeouts. Oh, the wait too takes time spec instead. Time spec is fun. I don't think we're gonna do time spec though. Wait. Wait, event thing. Just waiting it, no. No. EP. Very EP. What are you, events? Data? I don't know what data type actually is. Wait, your structure. You are a big structure. Array. We need an array. We need an array. Okay. We need an array. This would be wait. I got the EP. I got the other thing. The EP items. And then you got like the EP item counts, and then you gotta wait for some amount of time. Good evening. Hello? Welcome? Why can't I see the color blue? I'm like blind. Dearest dust. 071. You got a toot-to-do. During the Steins Gate themes. Yeah. Yeah. It's like premium quality right there. You create. Create. 100 million? A few 100 million bajillion. Oh, there's not actually that many items. You can't actually specify that many items. It doesn't work that way. It still very much does not work that way. Or you add this. This would be what? The EP. You are something? I'm like, you are the FD we want. And then you are the event. File descriptor. Something or other. I don't know if I'm allowed to do it like that. We might have to like nest like so. And events. It's probably this mess. I think. Wait, what do you return? So you allow catching signals. Return the number of file descriptors ready for requested I/O. Or failure. Failure. Failure is always an option, right? Totally acceptable. It's totally acceptable, really. Let's steal one of these airlines. I don't think we need these. Could be wrong about that. E-pool. Wait. So what do we need? We need an int. And you need to be like an e-poll creates or something. The empty. The empty. Big giant pool of E. Oh yeah, here. Control add. I'm gonna add thing. Data. Specifies the data that the kernel should save and then return. And this file descriptor becomes ready. Oh, so I can put whatever I want in there. Events is a bit mask composed of ORing. Just a little bit of comporing. Yeah. We've got edge trigger notification. A one-shot notification. A wake up. Wake me up. I need to wake up sometimes. Ensure that the system does not enter suspend or hibernate while this event is pending or being processed. Well, that sounds kind of powerful. Kind of, sorta. Alright, so, yeah, we add the item. And then you. We're just a -1 error kind of deal. And then I guess we're gonna have like a vector of epoll event. This would be data. Would be items size. You can be file descriptor pointer integers. 0. A very 0. Just a few items. Ugh, so many items. What are you? Amount to read? The amount to be read? I guess the API for that would be a little bit different. So we could just return false. The amount is 0. Probably. Probably. Probably, maybe, perhaps. Where is scan list? So event items, we sort of want to like size that to be able to hold a number of entries. Whenever we create this thing. As for how much, how many we reserve. I'm gonna say it depends on how many we scan. Also, we need to do this during init. Obviously, or maybe that's not obvious. Maybe that's not obvious. Let's put you up in the big giant list of variables, which is in the middle of everything for some reason. I'm not gonna pretend to know why I put that in the middle of everything, but I did. Scan devices, you need all them parameters. All those parameters, all those silly parameters. Silly parameter. Let's put this up here. So I have to reset them. Scan, run once. Let's just set that. And then if the if a gajillion would maybe work. Would it though? I don't know if I'd want it to. I think the kernel would look at me and go like, what? What are you doing? Size is ignored. Is it really? Epoll create one includes flags. Epoll create includes size. Since 2.6.8, the size argument is ignored but must be greater than 0. See history. Uh, 420. Perfect number. Oni Mesaka. Alright, so create function. We're gonna stick this inside init. I think. And then if we have backend, or no, if this is null, or the seat is active, then I think we will call scan devices. And then in here, we should have like the scan list size. And if that's more than event items size. We're going to take scan list size and we're going to use that as the basis for the event items. So I have plenty of room for all of them, should they all go at once, which I don't think they will, but you never know. Pull IO buffer from Nick. Non-pull soft something. Oh, this is this is very true. I won't argue there. Like, if you can busy wait for Nick input, it's a lot more responsive because you don't have to wait for like interrupt dispatch and you don't have to do like context switching and you don't have to do all that mess. But the IOU ring, I was reading about the IOU ring yesterday. It was yesterday. And I was thinking about something today that made me kind of curious. Which is like, if you put an item into the ring, and the item is like, it doesn't actually get fulfilled or something, does the kernel still like read the item out of the ring such that you can like overwrite it? Like if the ring rolls around and some of your items haven't fulfilled, I'm like, can you just overwrite their entries? Is this allowed? Because if it is, that would be kind of huge. And then I'd probably want to go with that for my, like, API instead of all this other stuff. Huge. Huge. Okay. So, I don't really know what the answer for it is. And I'm kind of wanting to, like, experiment. I kind of want to experiment with the U-ring. Maybe we'll get the E-pull working first, and then we'll play around with the U-ring a little bit. Cause I wanna try that. Cause it's not just input devices that I need to handle. It's like literally everything in the engine is gonna eventually need to like register itself. The IOE ring. The IOU ring lib. The kernel? I think my kernel should support everything. It's hella modern. Leading edge. Looks like U-Ring has been around for a while. I don't know why it wouldn't get supported. The only reason I could think to come up with support for some of these older technologies would be like reverse compatibility, and I don't know how much reverse compatibility I want to bake into this thing. Because the only thing that I would want to be reverse compatible with is like maybe Windows, but like yeah, that requires like some changes on the Vulkan side of things that are not present as of yet. The RCU list is bad. It's worse if you make the kernel. What do we word here? Race to read through the long list of RCU reads. You don't want a whole lot of RCU. Or is that supposed to be like ROC? I don't know. It's hard to tell what is typo and what is actually word because there's all kinds of algorithms. Why is this song so quiet? Can we just go to the next one? Right, what was I doing? We're gonna get the event items. Event items. ROCVE2 RDMA. Overconverged onto Ethernet. Right, ow. Ow. Not the Ethernet. Not the Ethernet. Not the anything about the Ethernet. I wrote an Ethernet driver once. A very simple one. Oh, that was an interesting chore. Round robin through the set of ready file descriptors. Help us avoid starvation. Oh, that's good at least. Just return these like in order, I think. I guess it just returned me like a list. Simple list. Ugh. So what do we got? We got event items. I don't know if R is 0. Return false because there's no items. And we got while. No. Well, R. Let's see, we need event item at R. Now we're gonna assume that whatever polling process has told me it is selected. Probably. This is event item events. Let's see, what kind of events were there? Did you have the list of events? Were they in here? I want to check for error or hang up. The FD is done for. It's done for. Otherwise, maybe like events poll in. Exceptional condition. What is an exceptional condition? Message of 0 length. Yeah, I don't know. I don't think we care either. So if you are, I guess, 0, also continue because there's no data to read. And then we would want to grab I guess it would be we could use, what can we use? I guess we'd use like the scan list index. New device, scan list, and then we'll get what the event item data U64. It's totally safe. Really, really. Until it isn't. You want to reference this. So what? Device. And we get device ID. I could type. I cannot type. I cannot type. Device ID. Nice file descriptor. You are device ID. You know, we should just have like a thing in here. You like could close it or whatever. Yeah, maybe we do that. To our top level close. Yeah. That way we could go in here. And then we grab device. I think. Probably. Maybe. Perhaps. We reset. Reset pointer. I think we would also have to like take the item out of the list. Control delete. Nice file descriptor. Can I have this null for deleting? Yeah. But see bugs. Okay, what are the bugs? Or 2.6.9. This required a non-null pointer. Even though this argument is ignored. Applications that need to be portable specify a non-null pointer. Don't care. What's that hydration? then, of course, there's the matter of, like, removing the device or whatever. Right. Then, then, then. I suppose I could glue those together. That seems like an idea. And then we need to register, like, all the devices. All of them. I think these go, like, one at a time. So we can just do... Find that registration code. Do I still have that? Or did I delete that? I think I might have gotten rid of that. E-poll event. The event of a lifetime. Let's see. We want in and just in. And then you can be the size of the scan list to get index. Yeah, you can be an index. Let's see what you get. File descriptor and the event. Oops. Ay, yeah, yeah. Ay, yeah, yeah. And sometimes I miss my relative line numbers, and sometimes I don't. Is it even possible to have both of them turned on? What the hell was that called? It's in Misaka Inins. Relative number. Relative number for all combinations. It's different. Of course it would be different. Always different. There are 4 combinations. We got number true. We got relative number. I don't think there's anything that shows like 2 sets of numbers though. Version. I don't know what version you are. Or version 12. 012. So, option C. Either. I don't think there's a way to get it to do what I want. But also, what I want kind of uses a lot of column space. This is already kind of a busy column. Because you got the get gutter, got the line numbers, got the regular margin. That's like 6 columns. And if we throw like relative numbers on top of that, that's like another. It's like another 3 columns. Template variables. Assign define. Highlighting group. That isn't it. That's highlighting nonsense. Number width. Is there anything else in here? RNU. Where did I land here? Status column. Determines the content of the area to the side of a window, normally containing full sign number columns. Some of the columns, items. Line number, fold column, line column, relative line number to be drawn, line number to be drawn. Not cause this unless this is set. So I need to set status column. So what do? We turn this on. I probably have to adjust the column width. We would set status column to something. Maybe something like that. Not entirely sure. Set. I can't tell if this is actually doing anything or not. Okay, that sort of did something. Sort of? Sort of? Maybe not the right kind of something. Known option. Do I have to put you in quotes? No? Put you in regular quotes? Maybe? Let's see, how many did I have to say that I need to make this thing? It needs to be 5 plus the extra 2, maybe, or 3, 7, 8, 9. 9 is a good number. Yeah, I don't know. I don't even know what this does. I don't even know what this does. You can meh. You want to? Leave your friends behind? If they don't meh? How do I space? I'm tempted to. Wouldn't be tempting. Don't give me excuses. You know I'm gonna end up making excuses. You don't evaluate though. Do I have to like put you? Okay, you evaluate things. And then if we have, what was the other one? Relative number? Yeah, pretty unreadable, that is. space? I can sort of see where the numbers are. Huh? Hmm. Line numbers in hexadecimal. Why, why would you want that? You know we gotta try it though, right? Yeah. Unclosed expression sequence. Is it though? Percent? I do not know what is unclosed about this. Is it you? It was you. And now we have hexadecimal line numbers. Oh, why would I do this? Why would I do this to myself? What if I make the relative numbers hexadecimal? Why would I do such a thing? Okay, that's very peculiar. Not fill it in with something else. I guess we'll set this one to 2. That should be enough. I think. I think that's fine. That seems fine. I feel like I want to edit this for some reason, but like, I don't know. I don't know. Let's wait. Get those. And then we need the gutter space. I think. Alright, so if I put this evil expression in here, you still like display. Okay, relative line numbers are broken because that's not and I don't think the number width is enough. What are you, 4? 7? space. No, we still have the space. Or even if we didn't have the space, that's not what I'm confusion about here. I don't have my signs anymore, my bit status. Totally need some space. Totally need some space. Totally need some space. Oh, that'd be it. That's a time. That's a bit of a time. Oh, yeah. Wait, so what if we clear the status column? You're just kind of empty. Well, now I'm kind of curious what the status column is printing in the ordinary case. 'Cause I'm not the only one that messes with that. We can mess with the status line. Like, get sucked down the rabbit hole. And just get sucked down the rabbit hole. Click separators. Click handlers. Click handlers. What is the sign callback? Or are you just... Or are you just a thing? Y-E. None of E. Oh, you're the signs. And then we can E. And then we can E, and then we can re. Then we can Yuki. Unironically, it's good filler. Then what do we got? We got percent. I don't even know what percent equals does in this case. There's just like a separator of some kind. Some kind of separator. Okay, so what are you? Yue. Sometimes we got that Yue. So you L. I guess that like right aligns things or some such. Or maybe it doesn't. I don't know. I got no idea. Oh, that's centers. Ah. Ay, yeah. Ay, yeah. You know, I kind of got sucked in a little bit. Kind of got sucked in a little bit. It's probably, maybe. Line number? Line number? Just tell me all the things. Maybe. Alignment sections. Very, very, I'll like take this. We got the relative hexadecimal numbers. That's a pretty fearsome status column option right there. Like for real. Like for real. Don't know if that's like enough or not. But like maybe. Let's see, what width do I need to make this stupid thing? Like 9 is kind of wide. Let's do like 7 or something. Maybe. Able to fit everything in 7 lines. I think we need the space. I think the space is important. Also, I think that's kind of we have to force it to be one way or another. Somehow. Probably. Probably. The numbers spill. That's weird. That is, shall we say, kind of weird. What if you are a space? What if you are not a space? If you are an aligned space. Make this the field 3. Should have picked a bigger file. Yeah. So how am I supposed to test if a file has like a bajillion lines in it? What then? I don't know what. We don't know. We don't know. Split the file? No, I gotta display all the line numbers. Because you know I'm gonna have like 10,000 line files, right? I'm gonna do it. It'll be 7. 7 should be fine. I think. Emphasis on should be. STC. So if we open this again. Kind of whatever. If we go into here, maybe. And we open what's very long main. I mean, I guess it's working okay. Main, aka all the code. Like, literally all of it. I think I also need to nix the indent expression nonsense. Oh, it's not Lua, it's here. Some of that auto load. What was in there, maybe? Or was it? Was it? I don't even know anymore. I don't know. We have state. You're just all that stuff. You're that stuff. I don't remember where I stuck the thing. Stuck some file in here somewhere. them? No, I don't think so. It's a local share? No, I don't think so. I swore there was some file somewhere. I don't know. I don't even know if I want to go looking for it. But we are, apparently. Why am I looking for this? Why am I looking around for this stuff? Let's not do that. Let's instead maybe we get up and take that break. Yes, that sounds like a great idea. Uh-huh, yeah. Yeah, we're gonna do that. Every time I take my little stretch breaks, my legs are like, are you sure about that? And then I'm like, yeah. Are you really sure about that? No. But I'll eat something if you comply. And then they're like, okay, maybe. Maybe just this once. Can we balance this back to... Was that minus 40? Ish? Alright, now that I got my messed up line numbers. So when I close that during cleanup. Let's see, you don't exist. Device in call it scan list. Skip the null ones. Device close. Device is a pointer. A smart-ish pointer. What am I looking for? Scan devices. I want to go here. Nothing. Nothing. I don't want to delete, I want to copy. If we have scan, and we don't have a backend where the seat is active, then we will scan the devices. Yeah. Yeah, yeah. Sort of, yeah, yeah. It's the demon. 26. Why would you do this? Why would you do this? Why would you do this to me? What did I ever do to deserve this? Wait, isn't this supposed to return something? E. It could just be less than or equal to 0. Well, that will catch it, right? We're gonna put that there anyway. Be explicit about it. I'm gonna be extra explicit about it. Right, so, in theory, this will either crash spectacularly or it will work perfectly. With absolutely no seg faults whatsoever. Although my bets are on the former. Because that's sort of how these things go. We got spectacular core dump. Because we got dispatch. This needs to be an else. Kind of important. It would appear that I was wrong on at least 2 different levels. It gets itself stuck. And it doesn't even scan the devices. Like, at all. But wait, if this failed, it should drop down into here. I guess this would be no. Or seat active. Okay, we got signed the wrong way around. This is maybe to be expected. What are you? Close device. Close device. Wait, why are we closing the device? Don't do that. Don't do that. It's always the little tiny things that get me. Okay, devices. So if we press buttons, we get events. we get all the different kinds of events from all the different things. Literally all the things. Literally all the things. We get keyboard, we get mouse, we get mouse clicks, we get little joystick thingies. I don't know if this is plugged in. It's not. If I poke at the little switches, then those send things. I would say that's mildly successful. Probably. Mildly successful. Yeah. Why so many bits? Why always so many bits? It's kind of freaky almost. Almost. You'd think I'd get vaguely used to it by now, or something. And maybe to some extent. Maybe to some extent. But, I don't know, it still gets me sometimes. Summon. One could not summon. Could never summon. And so, hello, and welcome to the Melanin. What else do I need to do this silly thing? We got devices. Oh wait, I think I was gonna categorize them. The ears are big. Big. Big, maybe? I don't know. This is the rumor. This is kind of the rumor. I think I was gonna try the U-ring. The IO U-ring. Oh my god. IO request. Read file, write file, accept socket, etc. Kind of etc. Refer to opcode documentation and IO U-ring enter for all supported opcodes and their properties. Wait for the number of events before returning. Ask the kernel to wake up the SQ thread to submit IO. Wait, if the ring was created with poll, then the application has no real insight into when the SQ kernel thread has consumed entries. This can lead to a situation where the application can no longer get a free SQE entry to submit without knowing when one will become available. Just the abridged water. Hello, hello. As for what you walk in on? Working on the input subsystem in my engine to make it capable of supporting the EV devices. These are like the device nodes that tell you like what all your input devices are doing. Like if you open one of the EV devices for like the keyboard, for example, it will send you events for like key presses, key releases, key repeats. If you open like a mouse device, it'll give you like mouse movements, keys down, key up. If you open like joystick devices, it will give you like position updates. If you open up like digitizers, like pen tablets, it will give you like pen coordinates or buttons and stuff, etc., so on and so forth. And if you were to write to like a joystick device, also welcome to the Yuki VT. But yeah, if you write to one of the joystick devices, then you can send it frames to tell it to apply force feedback or vibration effects or whatever. So if I run this, then like it gives me keyboard events, for example. We got mouse movement events. Got mouse click events. We got joystick events. These are kind of like absolute coordinates. We got joystick button events. There's also events that get sent when you like plug and unplug like headphones and speakers. 'Cause that's fun. Hello and welcome again, as always, to the Cabbage McGravel. Hi, welcome. So right now, the way I get events from the myriad quantity of devices is with this thing called an e-poll. Which we just set up. But there's this other API for doing like system calls. It's called uring. IO uring. Where you like memory map a ring buffer into your process, and then you can write like data structures to it. And then the kernel will read from the ring buffer and execute the things. The, the calls that you request. What are you breaking? What are we breaking? Let's enter restricted ring. Absolute timer, extended argument. The IO ring instance was configured for polling by specifying setup IO poll. Incomplete has a slightly different meaning. Get a runic assembly. Technically, it's just hexadecimal with a very funny encoding. Alright, what do we got in here? Do not perform any I/O. Vectored read and write. Fixed read and write. Fsync. Pull add. Pull the FD specified in the submission queue entry. The event specified. By default, this interface always works in one-shot mode. It is once the pull operation is completed, it will have to be resubmitted. you a rainbow? Is there a rainbow triangle in here? I don't see it. I do not see it. So many. Maybe on the screen preview I can see it. Yeah, there's one that's flashy floaty. Is it that one? Might be that one. Kind of makes me wonder if I should expedite adding that whole identifier thing. Pole add multi is set, then the pole will work in multi-shot mode. This means it will repeatedly trigger when the requested event becomes true? And henceforth, multiple CQEs can be generated from this single CQE. I always forget which one it is. Submission queue entry. Okay, got it. Right. Yeah. Flags field will have F more set on completion if the application should expect further CQE entries from the original request. CQE. If this flag isn't set, the pull request has been terminated and no further events will be generated. Write a Vue.js app rune to assembler. Maybe. Maybe. Gotta debug things more ergonomically. One of these days I'll get around to that whole web page thing with the assembler debugger on it. One of these days, yeah, that silly lazy May saga. Remove or update an existing pull request. All update events is set. The request will update an existing pull with the mask of events. poll control. Add, remove, or modify entries of the interest list of ePoll. Off holds the file descriptor to add, remove, modify. Lin holds the operation. Oh, that's kind of fun. Use sync file range. Don't care about that. Send message. Socket descriptor pointer to message header. Receive message. Poll first. If set, U-ring will assume the socket is currently empty and attempting to receive data will be unsuccessful. In this case, the ring will arm an internal poll and trigger a receive of the data when the socket has data to be read. This initial receive attempt can be wasteful for the case where the socket is expected to be empty. Setting the flag will bypass the initial receive attempt and go straight to arming poll. If poll does not indicate that data is ready to be received, the operation will proceed. Shiny buttons. With the shiny buttons. And with the shiny buttons. Send. Receive. Timeout. Timeout remove. Accept. Sync cancel. Have to cancel an already issued request. Link timeout. Linked with another request through IO link. As described below, unlike timeout, link timeout acts on the linked request, not the completion queue. I don't know what that means. To finish enough module, we should write that void flock. I mean, that is a goal. That is one of the overarching goals. We got connect. A connect system call. F allocate. F advise. M advise. Open at. Open at 2. Close. Stat. Read write. These are non-vectored versions of read v, write v. Splice. T. That is files update. I mean, colliding is actually not really any easier than like trying to determine like where the other ships are and give them the ability to respond. That's actually kind of one of the things that I'm like, I've been trying to, I don't know, I've been putting it off because I'm like, we can't just do an end-to-end comparison. That will give me like a very not great like response. Message bus. Event handlers. The event handlers. What the E? Talking like virtual events? Or are we talking like actual system events in some way? Collisions. Well, I mean, the thing is, though, the ships don't collide with each other as of yet. And I don't necessarily think that they're supposed to either. Issue the equivalent of a shutdown system call. Rename at. Unlink at. Make directory at. Symlink at. Link at. Message ring. Send a message to an IOU ring. File descriptor must be set to the file descriptor of a ring that the application has access to. Len can be any 32-bit value the application wishes to pass on. Off can be any 64-bit value that the application wishes to send. On the target ring, a CQE will be posted with the res field matching the len and a user data field matching the offset value being passed. This request type can be used to either just wake or interrupt anyone waiting for completions on the target ring. Or it can be used to pass messages between via the two fields. Chunky algorithms. If you need to optimize chunky algorithms, then I'll just make programs that run in like public memory or whatever go faster or something. A little bit worse something. Or maybe I'll make it so that you can like spawn threads in the public memory. That would be evil. Maybe. Maybe. But they can only run in the public memory. That would be crazy. That would be kind of crazy. You op socket. Create a socket. U-ring command. Per file private operation similar to IO control. The mining laser. The mining laser is another planned feature. Gotta get flight and nav done first, because those are kind of essential. Those public memory threads. Maybe. I don't exactly know how I'd want to make it work. Red Core Wars. Kind of, sort of. I mean, the shared memory space is kind of indirectly inspired by Core Wars. Believe it or not. Maybe you would believe it. I don't know. Although it doesn't have quite the same level of flexibility because reasons. Got the CSS. What am I looking for? Send 0 copy. I'm not reading all that. Send message 0 copy. I'm not reading all that. Wait ID. Set get f set f get x attribute. Bind. Listen. Truncate. Read multi-shot. It's like read, but similar to requests prepared with multi-shot except. Additional reads, thus CQEs, will be performed based on a single SQE once there is more data available. It is restricted to pullable files and will fall back to single shot if the file does not support no wait. So many features in this. Fixed FD install. Insert a registered file into the regular process file table. Flags field is a bit mask. What do we do? Fixed file. Register files. Drain. What are we draining here? The SQE will not be started before previously submitted SQEs have completed. And new SQEs will not be started before this one completes. Not touching that. That shared fish tech. And this is sort of why I have the emulator thing open source. So you can sort of try to write programs. I kind of did okay. But like, I think the page, I think the little debug page needs some more improvements. It does. I think I did upload the what's it called? Sort of needs to be more demand. Too many demands. So many demands. So many things to do. Although it's always so many things to do. Oh, link. This is what I wanted to read about. Forms a link with the next SQE in the submission ring. Next SQE will not be started before the previous request completes. The tail of the chain is denoted by the first SQE that does not have this flag set. Chains are not supported across submission boundaries. This means that multiple chains can be executing in parallel or chains individual SQEs. Only members inside the chain are serialized. IO hard link doesn't sever regardless of the completion result. Async. Normal operation for a U-ring is to try and issue an SQE as non-blocking. And if that fails, execute it in an async manner. Support more efficient overlapped operation of requests. the application knows, assumes, will always block. The application can ask for an SQE to be issued async from the start. When you do register a pool of buffers to be used by commands that read or receive data. When buffers are registered for this use case, the flag is set in the command. The uring will grab a buffer from this pool and then request when the request is ready to receive or read data. Or, yeah. Grab one from the pool when it's ready. If successful, the resulting CQE will have CQEF buffer set in the flags. And the upper CQE buffer shift bits will contain the ID of the selected buffers. This allows the application to know exactly which buffer was selected for the operation. If no buffers are available and this flag is set, then the request will fail with no buffers as the error code. Once a buffer has been used, it is no longer available in the kernel. Which is the May of the Saka, or maybe it's the myriad of the mines, or maybe it's just the myriad mines. Hello, hello, and welcome. We must give shout out for myriad mines. The myriad of the Saka. Skip success. Don't generate a CQE if the request completes successfully. This is, that's kind of fun. Why would you not want a success? IO priority specifies IO priority. File descriptor. The exception noted above. If the operation is read fixed or write fixed, address and length must fall within the buffer located at buffer index in the fixed buffer array. If the operation is either read v or write v, an address points to an IOVEC array of len entries. Read-write flags determine bitwise IO flags. Fsync flags bit mask may either contain 0 or a normal file integrity sync. The error? Wait, what error are we talking about here? Documentation. This is a manual page. Documentation. We got user data as application controlled value. It'll be copied into the completion queue entry. Buffer index is an index into an array of fixed buffers and is only valid if fixed buffers were registered. Personality is the credentials ID to use for this operation. Once the submission queue entry is initialized, I/O is submitted by placing the index of the submission queue entry into the tail of the submission queue. After one or more indexes are added to the queue tail is advanced. The I/O U-ring enter system call can be invoked to initiate the I/O. The I/O. The I/O. Completions use the following data structure. Got your user data, your res, and your flags. User data is copied from the submission queue entry. Primary use case is to store data that the application will use to access upon completion of the particular I/O. I/O. Flags are used for certain commands. Res is operation-specific result. The I/O U-ring specific errors are returned through this field. The I/O. For read and write opcodes, the return values match error no values, with res holding the equivalent of negative error no for error cases, or the transferred number of bytes in case the operation is successful. A U-ring enter returns the number of I/Os successfully consumed. The errors related to a submission queue entry will be returned through a completion queue entry rather than through the system call. Gotta love the funny words. The EO. We should just call it EO. Yo. EO. We're not doing input output. We're doing input outputs. Alright, so what do SQEs look like? They're a bunch of fields. Yummy. The input. Somewhere in here there was like an example of how to do the actual setup. Acquire a submission queue entry from the submission queue. Fill it up with all the details of your operation and call IO ring enter. If you want to avoid calling IO ring enter, you'll have the option of setting up submission queue polling. SQEs are added to the tail of the submission queue. The kernel picks up SQEs off of the head of the submission queue. General algorithm to get the next available SQE and update the tail is as follows. Dereference the tail. Get the ring mask. And it with the tail value to get an index. Get a reference to your SQE at the index. Describe all the things. Fill the SQE index into the SQ ring array. Increment your tail. Atomic store explicit ring tail. Might need to fence that a little bit. Get the index of an entry. The application must mask the current tail with the size of the ring. That's true for both SQs and CQs. Once the SQE is acquired, the necessary fields are filled in describing the request. Memory ordering, something memory ordering. Memory barriers. Something memory barriers. I don't know, it's all kind of interesting. Let's I guess let's commit these. So I'm gonna start breaking it. I might as well save what I did into a commit, because I don't do that usually. Usually I'm pretty lazy about it. This thing is being very slow. Why is it doing that? I don't know why I don't just add the whole file. I don't think there's anything in here that I need to really review much. Right? Right? Probably not. Probably not. Mm. Input system using ePOL for now. Remember, IOU ring is Linux specific. All the more fun. This means it's all the more fun. Definitely. Definitely, probably. This doesn't really have much to do with like the input system. So like intuitively one might assume that I should just put it in a different file. Maybe. I don't know though. We definitely need to like Do something here with this silly thing, though. Yum, 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 yum. Yum, 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 yum. Too much, yum, 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 yum. I don't know, it's a good stance. I think we're gonna need atomic. And a barrier? We need barrier. Yeah, those are tasty. Set up the ring of power. Set up the ring of power. Wait, do we really not have, like, IO U-ring setup? We don't have that. Okay. A syscall? That's fun. To do more syscalls. What are you? Entries. How do we put this kind of thing? IOU ring setup. Entries. IOU ring params. Pointer. I don't know if it matters because I'm really only going to call it like once, right? Right? We're only going to call it once. Surely. Enter, on the other hand. That's going to get called off a bunch of different times. Min nom. Unsigned slangs. I think it's basically just like uint 32 or whatever. Can I not assume that? I feel like I should be able to assume that. No. 0. E? I mean, no. I normally, yeah, I don't like assuming things. I don't, of course, but I also don't know what I'm in for here. Why does this take null? What are you? Enter 2, signal type. Size. Signal mask. If signal is not null, enter first replaces what's it called? It's not exactly very clear about that. It just reacts. Hello, hello, hi, welcome. Welcome, welcome. You know, I won't necessarily say that you have to understand software. Watch this channel. I feel like a lot of people don't understand the software. Especially not the crazy nonsense that I'm writing. Like, half the time I don't even understand some of the nonsense that I'm writing. That's maybe not entirely true. I'm probably selling myself short. Get the crazy nonsense. Get all that crazy nonsense. Alright, I guess this would mean that we need some IOU ring params. Whatever that means. It's my crazy nonsense. It's my crazy nonsense. And I will write it how I see fit. Features. Offsets. Are you a structure? Oh my god, you're a structure. Thread CPU, thread idle. As the shared ring buffers between kernel and user space, the IOU ring can be a zero-copy system. Copying buffers to and from becomes necessary when system calls that transfer data between the kernel and user space are involved. Since the bulk of the communication in an IOU ring is via buffers shared between the kernel and user space, this huge performance overhead is completely avoided. While system calls may not seem like a significant overhead, and high-performance applications make a lot of them will begin to matter. While workarounds the operating system has in place to deal with the Spectre and Meltdown are ideally best done away with. Unfortunately, some of these are around the system call interface, make system calls not as cheap as they are for something or other. Blah, blah, blah. In the IOU ring, on the other hand, you could batch several requests in one go simply by queuing them up and making a simple single call to IOU ring enter. Batching in and of itself can avoid overhead associated with potentially multiple and frequent system calls. You can reduce this overhead even further with submission queue polling by having the kernel poll, pick up your SQEs for processing as you add them to the submission queue. This avoids the IOU ring enter call. I don't know if I've seen a whole lot of people use the IOU ring. But then again, I don't exactly watch a whole lot of people try to use, like, the Linux kernel features, so I have no clue. I think people would be lining up to use it or something. With it being as fancy as it is. Do I have to build an abstraction around U-ring? Decisions, indecisions. Alright, so what the hell you do? You zero out the structure. And then we call IOU ring setup with the ring size or whatever. The ring queue depth. That's fine. $5 hours already? Because ITN int. I don't know, I'm very good at wasting time apparently. Sub ring size. Submission queue offset. array? Or a uint? The hell? I'm not dropping my signedness. SQ entries times size of. Oh, uint 32. And then completion queue offset. CQEs. CQ entries times uint. No. IO uring CQE. Just what we have in the CQEs array. The recommended way to check the features field. If IOU ring feature single memory map is set. You can do away with the second memory map. Feathers. I don't think my ring has feathers. What kind of features do we have here? Lots and lots and lots of things. The only one associated with memory is definitely the single mmap. What are we doing here? We're putting the completion ring, sending it to the source ring. Mapping the submission and completion queue. Kernels less than 5.4 only map the submission queue. Somewhere, Slightly, feel like I have to read more about that. The flag. Maybe read about this flag? Maybe? 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 We need... What's in cis? No address. Submission ring signs. Protection. Read? Protection right. Protection execute. We're not doing execute. That would be funny. Map shared. Map. (32-bit) above 4G anonymous droppable executable huge failed type sync stack private populate file descriptor. We want the ring. What do we want? IO ring offset SQ ring. Very be what? Void pointer. Maybe. Ring Q depth. I don't know, 1,000? Oh, I don't know what I need to put in this stupid thing. What's in here? We got the ring mask, the ring entries, the array, the flags, the head, tail, reserved user address. Ring entries. I wonder if there's a description of this structure somewhere. completion queue equals the submission queue. These useful fields, the tail. The tail offsets the ring mask, the array. Another memory map thingy if we need it. No, we're just gonna change those, make those nice and short, I think. Now we have to submit for map. We have to map the SQE. Lots of things. What are you for size? Rams. The SQ entries. The size of the IOU ring SQE. And then we got the CQE pointer. Is the CQ pointer the CQ offset? I very we can't quite do that. Maybe if you are a uint pointer, then we could make that happen. At least I assume. I don't know. Or that's how it should behave, given the C, I guess. Don't know about this offset here, though. If we need that or not. This thing be like features. Like this line up here, basically. And you're just the SQ pointer. Somehow. Somehow, and that's supposed to work. I don't know why that's supposed to work. What are you doing here? This is what? S ring? Maximum? C ring and S ring? I guess. It's kind of nonsense. It's kind of sort of nonsense almost. What are you? Array. So I guess this offset probably accounts for whatever. And then this offset accounts for whatever. Somehow. And then we gotta get the tail. We gotta get the tail. We gotta get the tail. The tail is important. I'll just like make these, I don't know, U8 pointers so I can calculate offsets to them in one piece. That'd be nice. Maybe. Are you void pointer? Oh no, I might have to make a void pointer actually. Never mind. No, I don't want that in there. I want that there. That there and that there and some of that there. Error. Never have enough errors, right? Right. No. And by no, I mean yes, actually. Actually, you can. You can have way too many errors. I don't want tons of errors. Clearly not. Oops. That's some silly nesting to be sure. Absolutely. Totally not confusing. %, Maisaka approved. Oh wait, I already have one of those. there like a pointer cast or something? No, we'll just do it sea flavored. I don't want to figure out how to cast it. I don't want to figure out how to cast it. Oh, no. Put you up there. Now we have a collection of pointers. I don't know if I need the sizes of things or not. But I definitely want, like, all the pointers. Because then I can shove all of them into a structure. A powerful something or other. A ring. The ring. No. A ring. That would be like ring dot. Probably. More rings. Hello and welcome to the Comrade's Soul. Deal with rings. I don't know if pizza are rings. Maybe they are, I don't know. What are the squeeze? Not void pointer, you are IOU ring squee. You are IOU ring quee. I am not a pizza. Maisaka is not a pizza. What did I do? I'm not even stealing any souls. These names are kind of cring. We put underscore in them. Or maybe we make all of them Q. Because why not? Because why not? And then we just kind of fill in like literally all of them. We got the SQ tail is the SQ pointer plus something. SQ offset of tail. Hello, what have we here? Clang desire to just stick random header again. What is up with that? What is up with that? What is ever up with any of that? Is there like a pointer cast? Reinterpret? Reinterpret? I think I could use you on pointers, right? Turn you into an IOU-ring SQE pointer. Maybe we could do static pointer casts or something, I don't know. Maybe? Maybe you? Maybe you. One of those silly functions. Yeah, I don't appreciate that weird indentation. That's excessive. Absolutely, 100%. Except that doesn't work. gonna we'll just do a regular one. Regular, boring, reinterpret cast. Everyone's favorite. So many layers. So many layers. Alright, what do you not like? You don't like being converted to an int32, which is, you know, kind of fair. Kind of, sort of fair. I don't know that I'd want to get randomly recast into a different pointer either. Kind of think that. Ring. Sikui. Sikui. Kui. Right, I got back to whatever. I got mask. And array. Very important. Space you out a little bit. As if I'm not spaced out already. There you head. Mask. I want to be able to type is what I want. Yep. So you're the mask. You are the head. I think. Yeah? Yeah. Yeah? Yeah. Yeah? Yeah. Yeah? Yeah. If this even works at all, I would be very, very shocked, I think. Probably. Who has the error? I'd be lazy with prefixes, apparently. Getting rid of them instead of doing whatever I need to do to clean up. We just sort of leave stuff strewn about everywhere. Fine, right? Future Mesaka will clean it up, right? Future Mesaka doesn't want to clean it up. Future Mesaka does not want to clean it up. Why are you making Future Mesaka clean it up? How does this setup function work? Flags, thread CPU, thread idle are used to configure the instance. The rings of power shall combine to summon forth the push toy. Form busy waiting for an IO completion as opposed to getting notifications via asynchronous IRQ. Tis the Penguin Operator. Hello, and again, welcome. What do we got here? Hybrid IO poll. I'm doing that. Just the crazy kitty. The numbers form. Yeah. The green circle has ruined me. I tell you, ruined me. Hello and welcome, though. Kernel thread is created to perform submission queue polling. Enables application to issue I/O without ever context switching into the kernel. You can submit things. There's so many people in the circle. The circle has certainly encountered some significant size. Your uwu ring. You're not uwu. Your ring? Are you uwu ring? Are you uwu ring? Are you uwu ring? Are you rang? Uwu rang? Are you affinity? CQ size. Create a completion queue with the specified number. Clamp. Attach. What are we attaching here? The U-ring instance being created will share the asynchronous worker thread background of the specified IOU ring. You ring. You ring. Submit all. When these requests results in an error, this can cause the submission of less than what is expected if a request ends in error while being submitted. The ring is created with this flag. Ring enter will continue submitting requests even if it encounters an error. CQEs are still posted for errored requests regardless of whether or not this flag is set at ring creation time. The only difference is if the submit sequence is halted or continued when an error is observed. Oops. Yeah, I kind of want that one. Set up submit all. Cooperative task run. IOU ring will interrupt a task running in user space. Then a completion event comes in. For a lot of use cases, this is overkill and cause reduced performance from both the interprocessor interrupt used to do this, the kernel to user level transition, and the needless interruption of tasks, user space activities, and reduced batching if completions come in at a rapid rate. Most applications don't need to use forceful interruption. Exceptions are setups where the application uses multiple threads operating on the same ring, or the application waiting on completions isn't one that submitted them. For most other use cases, setting this flag will improve performance. Like performance. Gimme. Available since 5.19. I don't know if we are in 5.19 or not. Sure, it would tell me, right? Conjunction with cooperative task run. This provides a flag SQ task run, which set in an SQ ring flags whenever completions are pending that should be processed. Normally convenient naming. Since when is Meisaka ever convenient? This is nonsense and a half. Libya ring will check the flag when doing peak. As of 5.19, only op uring command pass-through command needs this for NVMe pass-through. I botched reading that sentence. Yeah. What will this do? 32 bytes CQEs rather than normal 16-byte ones. And this is 128 byte SQEs rather than normal 64-byte size. Yeah, I don't know if I want to make my structures bigger intentionally or not. I'm not doing NVMe. Enter the kernel that a single task or thread will submit requests. Submission task is either the task that created the ring or the task that enables the ring through ring register. By default, the ring will process all outstanding work at the end of any system call or thread interrupt. I got mega hype. By default, the ring allocates kernel memory that callers must subsequently memory map. If this flag is set, the ring instead uses caller allocated buffers. Allocations must be contiguous memory. Oh, yeah, I'm not touching that. I'm not touching that. Register the ring file descriptor. No SQ array. Entries in the submission queue will be submitted in order, wrapping around to the first entry after reaching the end of the queue. Other words? In other words, wrapping around to the first entry after reaching the end of the queue. No more indirection via the array of submission entries, and the queue will be indexed directly by the submission queue tail. The range of index represented by it modulo the queue size. The user should not map the array of submission queue entries. The user should not map the array. No flags are specified. The IOU ring instance is set up for even interrupt driven IO. IO may be submitted using enter. It can be reaped by pulling the completion queue. Features is filled in by the kernel. The Joel. Mini Joel. Cursor position. Cursor pernality. Pernality. Pernality? That's not what that word says. Fast pull. Internal pull mechanism. Red registering. Red registering. Alright, what do we stick in these things? Because I'm curious. Entries specifies the number of submission queue entries allocated. SQ offset describes the offset of various ring buffer fields. The addition of off array to the length accounts for the fact that the ring is located at the end of the data structure. The ring buffer head pointer can be accessed by adding offset head to the address returned. We are, in this current moment, reading about the IOU ring construction parameters, so I know how this thing actually works. Just kind of randomly followed the example. I also want to know what some of the caveats are, because there's always a catch. And the catch is not always Joel. Closing the file descriptor will free all resources. Very eek. Integrating the engine input system. It's because we're technically integrating the input system. But maybe, just maybe, I want to use an IO U-ring interface to asynchronously request all of the event reads. It's a worthwhile effort because I wanted to set this up before, and this seems like the perfect place to do it. It's got like, we want to pull some devices, we want to read the devices, maybe do both at the same time. Eventually I'll also have like a bunch of sockets that will probably want to be read and written. I know there's a bunch of other like file system stuff that I kind of want to integrate with this thing. Like all my file read and write operations right now are they're just sort of like a bunch of read write system calls. And they're not particularly expeditious about it either. They don't really buffer too well. I think I'm also gonna have to find whatever that was, that API for watching directories to check for file and directory changes. Because the shader subsystem is supposed to support like watching the shader directory and then like hot reloading them if any of them change. Oh, that feature didn't get ported over yet. Probably won't for a while because I don't need it. Prefer the code in the sea? The unholy sea? As opposed to what? Rust? Evil Rust? C++, maybe? Lots of function pointers. Function pointers are fun. And nobody says you can't use function pointers on your structures in C++. Totally do that. Totally do that. As long as you don't have any objective things to force it to, like, do a thing. There is, like, way too much cruft in C++. I'll grant you that. I cannot argue with this fact. There are a handful of kind of nice features, but, like, features that I would realistically want to use are things that I kind of use, and features that I don't like, I'm like, nope, don't want that. I guess everyone writing C++ has their own opinion about what subset of features they want to use. But I gotta get that crafted. That crafty C. That crafty C. Got the Zmalik. Oh, got the Zmalik. Got the memory map. Got the Malik. Is this like the call chain or the pecking order? Decent preference, I would say. I don't think anyone likes Malik. I don't like Malik. I would sooner write my own allocator in user space. I wasn't terrible at it. What do you do? Set up ring. Submit. Submit ring read. Read from queue. Right? Read from queue. We submit to the queue. Submit yourself to the queue. I don't think calling it ring is probably the best idea. It would be the ring. The ring. This would be an ooh ring reference. Rust. It's because Rust is like kind of an obnoxious language in a little bit. Like I don't know. I kind of like Rust, but at the same time, they make a lot of stupid design decisions. Or they just don't implement everything. I've been like kind of wanting to like do some no standard unsafe Rust just to experiment with like how to write lower level programs in it. Lime or the lemon? I think I would pick lime. I like lime. The crust? I have seen this, yes. I actually watched him like come up with some of those rules. Kind of funny. That's what gave me the idea to actually try it, maybe. Although I'd probably do my own little take on it. Like, there's still some things that I like references for. I don't mind having references, borrows to things. To a degree. It's ugly. I, yeah, it's kind of hideous. It's deliberately fighting the language. That's the best part of it. It's a hideous mess. Can I like get their submit to the ring? What are we gonna send to the ring? File descriptor, an operator, 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 indexy, taily. I mean, Zig has better low-level primitives than like Rust. That's hardly surprising. have you seen Unsafe Rust? Some of the nonsense that you have to go through to make Unsafe Rust actually work. Ugh. You can wrap it in macros and stuff, but like, ugh. Ugh. Rust language is very opinionated, and it sort of only makes any semblance of sense for, I don't know, applications. Even then, it's not very good at that. Font. This font is, NV code R. What are my font commands? I haven't even used, like, VS Code in forever. Let's see, what was I doing? I was grabbing the tail. Tail. Which tail? This SQ tail.
Don't grab the tail. That's rude.
What if I wanted to grab the tail? I don't want to touch fluffy tail. What if we want the tail? What if we want submission queue? What are we doing here? Mask? Gotta mask the tail? Turn that into an index? Get an IO ring SQE? By reference? Sure. Ring or the SQE pointer. Index. Submit to the OO ring. The OO ring. Open. No, opcode. Opcode, opcode. Why are you opcode? Address? What is address? This points it at some sort of buffer. Zero. That's not the buffer. It's not the buffer. Can't be the buffer. And then what are they doing here? Op IO ring op read. They do mem set buffer. We don't have a buffer. The fluff buff. Thought I had too many parens for a second there. Mm, 4096, that's a good number. Let's write it like this. Wait, that's more than that, right? Right. That's too many. I just want a single page. Streaming. There's a lot of people who watch my streams, by the way. Schedule is the way it is because it needs to be the way it is. Length? I don't know. Size of the floppy buffy? I don't know. Otherwise, this can be a length. Look at these lengths. U32s? What are the opcodes? U8? Oh yeah. My eyes are fine. If you want stretch break, then you can redeem the stretch break. That's what that's there for. Offset. Offset. What is offset? This is another parameter that this example is introducing. Kind of, sort of. Yeah. When we're making an IO U-ring implementation for my like 3D slash whatever engine. I have like a 3D engine, and decided to like add a bunch of like window manager type features. The U-ring interface. This is like you tell the kernel to submit to set up your a ring for you, and then you have this big block of memory that you have to memory map into your process, and it's full of like these data structures that you can fill in, and the data structures let you do a lot of different things that you would normally do with like system calls. Like you can read and write files. You can like poll for events. You can set like timeouts. You can send messages to other rings. You can like close and open files. And like do like all the file system operations. Instead of like doing like individual system calls, you like fill in these data structures in the array, and then you like put like the index to the structure inside of like this other like ring buffer, and then you call like a ring buffer submit command, and then the kernel just goes and does it, and then you wait for the different events to complete. But seeing as how somebody redeemed stretch break. I'm gonna get up. I'm gonna stretch for a little bit. Um, it might be time to get myself another snack. Let's see, do I want to get another snack? I'm not entirely sure. I'm not entirely sure.